We have a number of ways of describing ratios, both in words and in mathematical notation. We saw one way of describing a ratio in words. In the previous video, we said the ratio of squares to circles is 2 to 3. So note the presence of the word ratio and the word 2. The word 2, when we're describing a ratio in this way, is used to separate the two quantities that we're relating. In this case, squares and circles. And notice the way that we actually described the numbers. Squares, and then this word 2, circles. Notice 2 was the number of squares, and 3 was the number of circles. The numbers have to come in the same order as the names. We could describe the same relationship by saying the ratio of circles to squares is 3 to 2. Notice we switched the order of the words. We had to also switch the order of the numbers. These describe the same relationship. So the order is important to note. If I ask you for the ratio of squares to circles, and you give me the ratio of circles to squares, that's just wrong. So again, the numbers come in the same order as the names of the quantities when we're describing the ratio. In addition to using the word 2, there are two other ways that we can write a ratio. The simplest thing that we can do is to replace the word 2 with a colon. So we can write 3:2 to mean the ratio 3 to 2. Or, here's the third thing we can do. We can write a ratio in fraction notation. So instead of the colon or the word 2, we're going to write a fraction bar. What order should they come in? When we write a ratio in fraction notation, we want to put the first quantity in the numerator, the second quantity in the denominator. So when we have a ratio in fraction notation, the ratio is numerator to denominator. And this idea of writing a ratio in fraction notation comes back to the idea of proportionality, doesn't it? We can write an equivalent ratio by multiplying each number by the same thing. Right? So as we saw earlier, and this is easiest to see in fraction notation because we're used to playing this game with fractions. The ratio 3 to 2, 3 circles for every 2 squares, is the same as, well, we could take 4 units like this. So we could have 4 groups of 3 circles, 4 groups of 2 squares. We could have 12 circles and 8 squares. Notice, however, there's no reason to have only whole numbers involved. One place we often find proportional quantities is in recipes. Suppose in a certain recipe we use 2½ cups of flour and 1 3/4 cups of milk. Then the ratio of flour to milk is, well, we could write it using the word 2, using a colon, or in fraction notation. Notice for the moment that these are both measured in cups. We'll talk about units of measure shortly. These are both in cups, so we can ignore them. The ratio is 2½ to 1 3/4. Or using the colon, 2½ colon 1 3/4. Or in fraction notation, 2½ over 1 3/4. In fraction notation, a ratio will often be a complex fraction. Now there are a couple of complications in describing ratios. The first complication is that we can describe ratios of more than 2 quantities. So for example, I could say we have a certain triangle where the sides have lengths in a ratio of 2 to 3 to 4. What does that mean? Well, it means the first side's length is 2 times something. The second side's length is 3 times that same thing. And the third side's length is 4 times that same thing again. So we might have, for example, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, and that would give us a triangle that looks like this. Or we could just as well have had, for example, 2 times 4, 3 times 4, 4 times 4. So 8, 12, 16, which would give us a triangle that's a little bit bigger, but roughly the same shape. The main reason that this is a complication is if we're describing a ratio of more than 2 quantities, we can't use fraction notation. We can use the word 2, or we can use the colon, but we can't use fraction notation because a fraction has just one numerator and just one denominator, which makes these sorts of computations a little bit more awkward, but not that bad, because again, we're just multiplying each number by the same thing. Another thing to be on the lookout for is when we're describing a ratio in English, we don't always use the word ratio. So we might say, for example, a company employs 3 women for every 2 men. That sentence means the same as to say that the ratio of women to men is 3 to 2. Or we might say, pasta sauce is on sale, 3 jars for $5. That means that if I go to the store and buy pasta sauce, the ratio of jars I get to dollars I pay is 3 to 5. So in general, we should be on the lookout for any problem that suggests that if I multiply one quantity by a number, I must multiply the other quantity by the same number. In other words, I should look for language that suggests proportionality.